Alright, and here we go with 5.2, where we're expanding upon that idea of multiplying and dividing radicals. Now, we've kind of done a few of these already in simple forms. We're just going to continue expanding upon this idea. So, we've already, just said that. When multiplying and dividing radicals, the index must be the same, but the radicand does not need to be the same. We know that two radicals with the same index, when multiplied, can be rewritten as radicand times radicand, all under the radical sign. What happens when we have to use the distributive property, or FOILing? Alright, so let's state these in simplest form. So, I have 2 root 2 times 3 root 5 plus 6 root 3. What we're going to be using is the distributive property. So I'm going to start by multiplying this number, and then multiplying this number, and this number. I'll have two terms, which will seemingly, or possibly not, look like they can be simplified. So let's just do that first. So multiplying, we multiply coefficients. So I'll do the yellow one first. 2 times 3 is 6. And then we multiply the radicands. 2 times 5 is 10. Now I'm multiplying 2 times 6 is 12. Root 2 times root 3 is root 6. Seemingly, it appears that we're done because the radicands are different. We can't add them. Well, let's just confirm that they can't be simplified. 10 would be 2 and 5. No. 6 would be 2 and 3. No. That being said, we have gone through this process and simplified this as far as we can. So 2 root 2 times 3 root 5 plus 6 root 3 equals 6 root 10 plus 12 root 6. So that's the distributive property, where we distribute this term outside the brackets into each term in the brackets. The second one we're going to do is FOILing. So 5 root 3 plus 6 root 2 squared. Well, what does that look like? Well, squared means that we're taking everything in this bracket and multiplying it by itself once more. This time, we're taking the first term, multiplying it by, or taking our first terms, so that's the F. Then we're multiplying our outside terms, that's the O. And then we're taking our inside terms, that's the I. And then finally our last terms, that's the L. Alright, so first terms. 5 root 3 times 5 root 3. Multiply those coefficients. 25 root, and then multiply those radicands. 3 times 3 is 9. Now let's do our outside ones. I told you that wrong, sorry. First is the pink. Outside is orange. Inside is green. And last is blue. Sorry about that. Okay. So that was our first. Now we're going to do our outside. So 5 root 3 times 6 root 2. Multiply those coefficients. So 5 times 6 is 30. Multiply those radicands. Root 3 times root 2 is root 6. Now our inside. So our inside is that green one. 6 root 2 times 5 root 3. So 6 times 5 is 30. Root 2 times root 3 is root 6. And finally our last, which is that blue. 6 times 6 is 36. Root 2 times root 2 is 4. Now there's a couple things we need to do here. Can we simplify any of these radicals? Well, root 9 is actually equal to 3. Root 4 is actually equal to 2. And then we can combine these two because they have like radicands. So this would be 60 root 6 plus 36 times 2 plus 25 times 3. 75 plus 60 root 6 plus 72. This is 147 plus 60 root 6. And root 6 can't be simplified any further, but this is our final answer. How can we verify that this is correct? Well, in our calculator, we can type 5 root 3 plus 6 root 2, square it, which equals 293.96, which should equal the same thing as 147 plus 60 root 6. And it does. Therefore, we are correct. All right. The biggest thing that, my biggest pet peeve, I should say, is when students do these questions and give me decimals. We're at the point where we're working with radicals, exact values. Do not give me decimals. That is not the point of this chapter. All right. So use decimals to verify, but do not use decimals as your solution. Now let's try and state these in simplest form on your own. So go ahead and come back. I'll have the answers for you, and I'll go over the second one just because it's a little tougher. Alright, our first one is pretty simple. 4 root 2 times 7 root 5 is 4 times 7 root 2 times 5, which simplifies down to 28 root 10. Then that 4 root 2 times root 3, so 4 times 1 is 4, root 2 times root 3 is root 6. What we need to be aware of is that if this was a negative, this would become negative as well. So just make sure you're paying attention to your positives and your negatives. The second question is much the same, it's just more work. So I have my first terms, 5 root 3 times 5 root 3, so 5 times 5 and root 3 times root 3, simplifies down to 25 root 9, which simplifies to 25 times 3, which simplifies to 75. And then I have my outside terms. 5 root 3 times 2 root 6 is 5 times 2 times root 6 times root 3, which simplifies to 10 root 18. And then I have my inside terms, 2 root 6 times 5 root 3, which is the same process, which simplifies down to 10 root 18. And then finally I have my last terms, 2 root 6 times 2 root 6, which is 4 root 36, which simplifies to 4 times 6, which simplifies to 24. Those 10 plus root 18s simplify down to 20 root 18. And then again, we combine all our like terms to end up with 99 plus 20 root 18. Can I simplify root 18? So I have 99 plus 20 root 18, which simplifies to 99 plus 20 root 9 times 2, which simplifies to 99 plus 20 times 3 root 2, 99 plus 60 root 2. You need to be aware that if we plugged this into our calculator, plugged this into our calculator, it would have equaled the same thing, but it wouldn't have been the simplest form. This is our simplest form. All right. And dividing radicals, like I said, we've already done a little bit. So 4 root 15 over 2 root 3. When dividing radicals, we separate the coefficients from the radicals. We simplify the coefficients if we can. Then we again realize that a radical divided by radical can be combined under one radical sign. So all I did is I split this up into two fractions. We know with fractions that we can split them up like this. Like 2x divided by 4x is the same as 2 over 4 times x over x. Okay, so hopefully you see what I'm doing there. Then I can simplify the coefficients. So 4 divided by 2 is equal to 2. Root 15 divided by root 3 seems complicated, but it's the same as root 15 over 3, which is the same as 2 root 5. Again, we might have to simplify this mixed radical, but in this case it is in simplest form. Alright, so here we have 2 root 20 divided by root 5. If you want, you can write this as 1 root 5, just to help yourself out. We can break this up into two fractions, 2 divided by 1 times root 20 over root 5, which is the same as 2 times root 20 over 5, which is the same as 2 times root 4, or 2 root 4. Again, this can be simplified though because root 4 is equal to 2, so we actually have 2 times 2, or 4. Alright. I'm going a bit fast because I think by now you should be able to know that root 4 is 2. Shouldn't have to go through that explanation. That being said, if any time during these explanations you are thinking to yourself, what the heck is he doing? Please make sure you let me know so I can elaborate. Now we have something called rationalizing the denominator. So this question can be solved in a couple of different ways. One of the simplest ways is by rationalizing the denominator. What that means is we multiply the top and the bottom by root 3, by that radical that's in the denominator. The reason that we do this is in order to get rid of the radical in the denominator. Kind of a basic math rule that you're going to have to learn is we don't want radicals in the denominator. Rationalizing gets rid of radicals in the denominator. And doing so also allows us to simplify our expression. So I'm just going to write this out on the iPad and then we'll look at it. Okay. So to rationalize the denominator, I'm going to multiply the top and the bottom by the radical in the denominator, just the radical. Why can I do this? Well, root 3 divided by root 3 is equal to 1. So really, again, I'm just changing the form of this equation. I'm not actually changing the value. Okay, I'm finding an equivalent fraction. So in this case, we need to know multiplication of radicals because we're doing distributive property. So 4 root 12 times root 3 is 4 root 36. Minus 10 root 6 times root 3 is minus 10 root 18. This will all be over 2 root 3 times root 3, which is 2 root 9. And again, this whole process was to get rid of that radical in the denominator. So let's just continue to simplify. 4 root 36 will actually equal 6 minus 10 root 18. I think that root 18 will be able to be simplified after. 2 root 9 is the same as 2 times 3. 4 times 6 is 24 minus 10 root 18. Let's break that 18 down into 9 times 2 all over 6. 24 minus 10 root 9 times root 2 is root 3 times root 2 all over 6. 24 minus 30 root 2 over 6. Now what some of you are going to do is say, oh, well, 24 minus 30. Nope, can't do that. You have to do multiplication first, so remember BEDMAS. That being said, we can simplify this because all of these numbers are divisible by 6. So we'll take a 6 out of each one. So 4 minus 5 root 2 over 1, which is 4 minus 5 root 2. So the simplified form of this is 4 minus 5 root 2. And we got there through the process of rationalizing the denominator. Alright? And again, you can verify that our initial expression is equal to our final expression using your calculator using decimals. So that's the first way to solve this, is by rationalizing the denominator. The second way is by finding those greatest common factors. So we're going to do the exact same question, but this time I'm going to take out my greatest common factors. Alright, so what are my greatest common factors? Well, we can take out a 2 from each of these. So let's divide everything by 2. So we'll be left with 2 root 12 minus 5 root 6 over root 3. What else can I do? Well, I can divide everything by a root 3. So that would be 2 root 4 minus 5 root 2 over 1. Okay, I can get rid of that 1. And from here I can just simplify. 2 times root 4 is 2 times 2 minus 5 root 2. 4 minus 5 root 2. Alright, and that was the exact same answer that we ended up with here. So this was greatest common factors, kind of dividing it out, pulling it out, etc. Okay. And our third way is by splitting a fraction. So like I said earlier, 3 over 4 minus 2 over 4 is the same as 3 minus 2 over 4. Or we can break this up into 3 over 4 minus 2 over 4. So let's break up our 4 root 12 minus 10 root 6 over 2 root 3? 2 root 3. So we can actually break this up into two fractions. 4 root 12 divided by 2 root 3 minus 10 root 6 over 2 root 3. Divide my coefficients. 4 divided by 2 is 2. Root 12 divided by root 3 is root 4. Minus 10 divided by 2 is 5. Root 6 divided by root 3 is root 2. And then again continue with that simplification. Bedmass 4 minus 5 root 2. So when dividing fractions, when dividing a binomial by a monomial, use whichever of these three strategies works best for you, whichever is most efficient for you, whichever makes you feel confident. Now let's pause and practice solving these three. Solve by rationalizing, greatest common factor, or splitting the fraction. I will do... what am I going to do? What do I want to do? I'll do it how I see fit, and then hopefully our answers will match. I'm not going to explain the first two, but I will explain the last one. So take a minute to do those on your own, come back, and we'll work through them, or we'll work through one together. Alright, here's that first question. On the top here, what I did is I used that breaking down into fractions, and it was a pretty straightforward process. I ended up with 6 root 2. Now, like I said, you can solve any way that you want. That being said, sometimes like rationalizing the denominator wouldn't actually be efficient. So here I rationalized by multiplying the top and the bottom by root 6, but then I ended up with this really big number, 2 root 288. Luckily, I was able to find those perfect squares pretty fast, but if you were doing that and you had to use prime factorization, it would take quite a long time. And then you get to this point, and at this point you need to continue to simplify, and you would get to 6 root 2. It just takes a lot longer, it takes a couple more steps. That being said, as long as you get to 6 root 2, I am happy. You might just not be happy because you spent too much time rationalizing the denominator. This second one, I would just focus on using that division. Using rationalizing, it would actually be a very long process, very arduous, and wouldn't get you to the answer easily. But you should end up with 2 root 2x. Alright? The hardest part here would be this division here. Just remember, divide the coefficients. 24 divided by 3, x squared divided by x is 8x. And then 8x can be simplified into 2 root 2x. This one is a little more complicated. I would use rationalizing the denominator. So I'm going to multiply the top and the bottom by that root in the denominator. So just root 5, not 3 root 5. And then again, distributive property. So root 80 times root 5 is root 400. Root 5 times 2 root 3 is 2 root 15. All over 3 root 25. Now just make sure you simplify your roots. Root 400, I believe, is a perfect square. So that's going to be 20 plus 2 root 15 all over 3 root 25, which is 3 times 5. 20 plus 2 root 15 over 15. In this case, I don't think we can simplify any further. Let me just look. 5 and 3, nope. So this should be your answer for that question. And again, you can verify by plugging it into your calculator. 2 plus 2 root 15 divided by 15 is 1.84. And root 80 plus 2 root 3 divided by 3 root 5. Oh, maybe I did something wrong. Give me a second. I did do it correctly. It's just when you type in your calculator, if you do a number divided by 3 root 5 and you just type in 3 root 5, what it's going to do is divide this number by 3 and then multiply it by root 5. So when you're typing radicals into your calculator, make sure you type in the number divided by bracket 3 root 5. You need to tell your calculator to do this first. Otherwise, it thinks that it needs to do the division first. So it divide by 3 if you don't tell it that this needs to be done first, by putting it into brackets. Alright. And one final skill, and then we're going to do a word problem. So our final skill is the conjugate. So rationalizing the denominator when the denominator contains a binomial requires knowledge of conjugates. So what is a conjugate? So in this one, 6 over 4, what was it? root 4x plus 1. My conjugate is going to be root 4 minus 1. Root 4 minus 1. Now, what is this going to do? Well, this is similar to that difference of squares that you learned about in chapter 3 and 4. By multiplying this and this, what we're actually going to do is get rid of those middle terms, remember? So we actually end up with something much simpler. So let's go through the process and you'll see what I mean. So again, we need to remember that this is foiling and 4x. This is foiling and distributive property. So 6 times root 4x is 6 root 4x. 6 times negative 1 is negative 6. This will all be over, and here we're going to have to do foiling. So first, root 4x times root 4x is root 16x squared. Root 4x times negative 1 is negative root 4x. Positive 1 times root 4x is plus root 4x. So see, that's what I'm talking about, canceling out those middle terms. And finally, 1 times negative 1 is negative 1. Let's go through with simplifying this. So 6 root 4x would be 6 times 2 root x, because that 4 can be square rooted, minus 6, all over 16x squared is a perfect square, so that would be 4x, minus root 4x plus root 4x is 0 minus 1. And then that's going to be 12 root x minus 6 over 4x minus 1. And as you see, we got rid of that radical sign, that root in the denominator, and simplified. And we've just simplified everything as far as we could, I believe. Yes. Okay. Now there's something we need to remember, and that is restrictions. We know that in fractions, our denominator cannot equal 0. So therefore, 4x minus 1 cannot equal 0. So what does that mean x cannot equal? Well, we need to isolate x here. So x cannot equal 1/4. So this is also something I want you to start doing, is stating restrictions on x. All right, so your final solution here would look, would look like this. And you're probably thinking, well, that doesn't look much more simple. Well, it doesn't. But simplification in terms of radicals just means that there's, well, it's simplified, of course, like we've been doing, but also if we get that radical out of the denominator, that is also a form of simplifying. And our final question, what is the volume of this prism? So first we need to think of, well, what is the volume of a triangular prism? Well, a triangular prism, or triangle-based prism, is a triangle, and essentially we just repeat that triangle over and over and over to fill up the space. So our triangle is base height divided by 2 times the length of my prism. Now on a test, I wouldn't expect you to create this formula on your own, but that being said, by this level, you should be able to. So, looking at my triangle, I have a base of 3 root 2. I have a height of 5 root 7. And I have a length of 7 root 14. So now what I need to do is just plug these numbers into my formula that I created, simplify, and I'll have my final answer. So 3 root 2 times 5 root 2 divided by 2 times 7 root 14 equals my volume. 3 root 2 times 5 root 2 is going to be 15 root 4 divided by 2 times 7 root 14. 15 root 4 is the same as 15 times 2 divided by 2 times 7 root 14, which is 30 over 2 times 7 root 14. Some of us might do this a different way. You might recognize shortcuts. 30 divided by 2 is 15 times 7 root 14. We can just multiply these straight across to get 15 times 7 is 105 root 14. Why can I do that? Well, essentially, we can look at 15 as 15 times root 1. Root 1 is 1, so we can state this as a radical. Can 14 be simplified? 2 times 7? No. So our final answer is 105 root 14. Is this in centimeters? Centimeters cubed. All right. So this tested our ability to multiply, to simplify, and to plug into a formula. And that is it for 5.2. At the end of 5.2, you need to be able to say, I can multiply and divide radicals and state them in their simplest forms. I can use the distributive property to multiply. I can rationalize a denominator, which includes multiplying by the conjugate. And I can use the greatest common factor to divide. And I can split those fractions up to help me simplify. And of course, apply all of that to word problems as well. That is it for Chapter 5.2. Please let me know if you need help, if you need me to review something, or if you need those practice sheets, like I said, to practice those radicals. If you don't have a strong foundation of radical work, this can be quite hard. I remember in grade 10, I had no clue how to work with radicals, and now looking back, I'm like, oh, it makes so much sense now. So hopefully I can help shed some light on those issues if you have them. Please move on to 5.3, and I'll talk to you soon.